when I'm looking at fan energy index incorporating into our design process, whether you're designing the building or even me as a manufacturer, there's really three areas that it's going to hit, and that's fan design, motor type, and fan size, right? And when we look at fan design, there are different types of impellers. There's the propeller, the centrifugal wheel, there's mixed flow. Um, the different type of impellers are going to have different ranges of where they're more efficient, right? A propeller is much more efficient at moving high volumes of air against very low static pressures. A centrifugal wheel is going to be much better at higher static pressures but lower volumes. So if you're looking to get, that minimum 1.0 or 1.1, whatever is needed, looking at alternate fans may become part of your equation now, and doing a good comparison of where is that fan moving in in an efficient point. But then there's motor technology as well. I have, in the single phase world, this is very evident, right? If I have a single phase AC induction motor, the motors are not very efficient, just by design. All right. So in that realm, I'm showing on the screen an EC motor, electronically commutated motor, which in single phase, I mean, that motor is sitting 85% efficient. I mean, it's an extremely efficient design. When you get up into the three-phase world, three-phase AC motors are much more efficient. But there's also EC motors that are even more efficient yet up in that range. To give you an idea, like a 2-horse AC induction motor is going to usually be around 86.5% efficient, which is really good. An EC motor at 2-horse, you can get them upwards of 91% efficient, right? So your gains are smaller, but more, impact the wallet more as far as savings, picking up that 5 or 10% on that end. Also under motor type, I kind of want to throw in VFDs with EC motors. VFDs, again, EC motors, VFDs allow you an easy way to change RPM. So you can take a bigger fan, slow it down, and get into that efficient spot. Also, if you're doing a variable volume design for your building, I can move 2 different points of air, 3 different points of air, occupied, unoccupied, normal, and alarm. I have that range of capability because of the motor technology. And then kind of that last point I made on the previous screen, right? Fan size is the next thing. Today I might use that smaller fan shown on the screen. Tomorrow, to hit higher FEIs that are required, one of the things I should be looking at is, okay, can I up the motor technology? Can I go from AC to EC? How much efficiency does that pick me up in that design? But you may also want to look at, okay, I need to bump this up to an 18 or a 20-inch wheel in order to get me to where I need to go efficiency-wise.